Well, welcome. Thank you all for coming today, even with the big game happening. We'll find out the score when it's all over. Or you can share as you want as we go through this lesson.
When we get something out of a dictionary, it doesn't know that that thing is actually going to exist. And so, for example, we added Robert, but what if we forget that and we thought we added Bob? Let's try to get Bob out of there. So all I did is copied the dictionary Jill and then pasted it below, and I'm typing Bob in there. And we see that we get nil because we didn't put Bob in our dictionary, we put Robert. And so what it returns is an optional, in this case, int. So, so that means it can be nil or it can actually be the number itself. And in order to use the thing that we get out, so we want to use Jill's age. So let's make a var and we'll call it Jill's age times 2. I'm going to copy for Jill, and then I'm going to multiply it by 2. Well, we get an error. We can't use it because it's an optional value, and you can't do math on an optional. So we can put an exclamation point. And that means that we're force unwrapping it. So we're saying we know that Jill's in our dictionary, and we know we're going to get a real integer back. So we can use it to do math with.
So dictionary Jill is the kind of object or not number.
It's an optional. Yeah.
Optional.
Yeah. Mm-hmm. Yeah.
You said that because when I take out the exclamation mark, I get an error.
Yes.
And like a red dot in the left margin.
Yes.
When I take it in, when I get the dot.
Yes. So this error,
Yeah, that error.
it says value of optional type int question mark not unwrapped. I'm sorry to see this too much.
Yeah, thanks.
So we just opened up a new playground. Yeah.
So what does unwrapped mean?
Yeah. So when something is optional, it can be nil or the number, right? And so the compiler doesn't know like if it's actually going to be a real number or not. So you have to tell it, yes, we're sure this is a real number. So this is the way to kind of cheat and say, I know for sure that Jill's in our dictionary. But a lot of times in a real app, you wouldn't know for sure that Jill's in the dictionary.
Like, trust me.
Yeah, right. So this is not the real way to do it. So let's comment that out.
So that means sometimes using exclamation mark is kind of dangerous.
Yes. In fact, you want to try to avoid that as much as possible. So instead, what we're going to do is we'll say we'll have Jill's age times 2, but this time we're not going to use it right now. We're going to just declare it. So we're going to say that's going to be an int. So it's colon and then int with a capital I. And we're going to use the if let syntax. So if let Jill's age I'll give you guys a minute to type that.
Would you want to cast it as an optional int? Because if that fails, you won't actually end up with the value there. And if you use it somewhere else, thinking that you have it.
Oh, well, yeah. I mean, well, we could just use, Jill's age for that instead, but in this case, we'll see where we'll use an optional later. Yeah. Yep.
Is it possibly covered this?
Mm-hmm.
Is it possible wherever it makes sense to define sentinel value cell? My notion of a nil or an age could be 0.
Yes.
Is it possible to
Yes. So instead of doing this, where we're just declaring it without anything, we could instead do it like this. And so now it's initialized to 0, and we can see that in the sidebar.
So if Jill is not in dictionary, it will be a non-null value and it will be 0.
Yeah.
I.e.
Yeah.
throw exception.
Right. Yeah. So and we could write that instead with our if statement. So let's go ahead and do that. We can capitalize that. So now if Jill is not in the dictionary, then Jill's h times 2 is going to be 0. And so the if let, what it does is it checks, so whatever you have on the right side of the equals is going to be something optional. And so if it's not nil, meaning it has a value, then we can actually use this Jill's age in whatever the statement is inside of the if statement. So now let's use that in practice. Let's make a little kind of sample. And we're gonna search our dictionary for someone. So we're gonna write a function. Let me go up. It's called search, and we're gonna pass in who, which will be a string. And then we're going to return, so we have a dash and angle bracket and then string. So we pass in a string and we return a string. And then we can say for name age in our dictionary. If the name that we found in the dictionary is equal to the who that we passed in, then we'll return that age. Oh, yep. Fetch. Oh, yep. Did I do that wrong? Yep, you're right. We're going to return an optional int. My bad.
Again, what is the hyphen, like a dash and greater?
So this means this is our function name,
Yeah.
and then we're going to return
Return.
this thing. Yeah,
The return type should be integer.
Yeah.
I see.
optional integer. Yeah.
Again, first to be optional.
Yes. So because if we find the person in our dictionary, we'll give back their age, which is a number, just an integer. If we don't find it, then we're going to return nil. So that means this. So when we say this, it means we're going to return either a number or nil. Nothing.
So the question mark is just to say it's just to provide for
The case where it's nil. Yeah. Yeah. Exactly.
This case always integer or nil.
Yeah.
But well, it's a wrapped integer, right? It's not.
Yes, to do something, we have to, unwrap it, So let's do that now. We can use our if let that we just learned. If let age equals search, and then we'll pass in somebody that's not there, so doc. Then we can print line this person is so in here we learned a new thing. You can use the backslash and open and close parentheses to have any kind of an expression inside of a string. So you can use variable names, you can call functions, you can do math. So any of that inside of a string, and then it'll actually print that out.
Do you have to bother with the printf kind of format specifiers, or can you get away with all of that? It just sorts
It just sorts it all out, yeah. You don't have
so
to do
even
that.
if you want like a decimal with 2 points afterwards,
Oh, then yes, then you have to do that.
then you have to
But so it's not showing anything because doc doesn't exist. But remember we had Jill up there, so let's type Jill instead of doc. And now we get this person's 52 printed out on the side for us. So now let's give it the else case, just so that we have that. We're going to print line, and in the string we'll say this person wasn't found. Let me close some things down here. Okay. So now if we switch it back to doc, now the sidebar says this person wasn't found. So any questions on how that's all working?
bother with doing something like this.
What it means that any type can now have a nil. So, which
But
is
an object can have a nil before. You can have an S nil.
yes. So, but this makes it safer. So you should have less crashes now than you would previously. Yeah.
It also forces the compiler that you have to deal with all of the possible cases. The compiler makes you deal with that, whereas before you had to deal with it by just having things crash and fixing it.
Right.
And I guess the other advantage would be when you start changing this. NS now it might change without.
Cool. So another cool thing that you can do is kind of prototype your views. So let's do a little bit of that here. So if we have a constant named word, so let word equals hello, and then we let a color equal UI color dot cyan color. then in the sidebar, we actually see the color that we just made. So that's kind of a handy feature. And okay, we'll go through this. This is going to be a lot of typing, but we're going to make it. Let a font equal UI font dot system UI kit. Is it not working for you? Oh, okay. Yeah. So when you started the playground, you selected Mac instead of iOS. I think you have to do a couple more steps other than that, so it might be better to just like make a new playground. So we're going to get font size 42. And then an attributed string is a string that has a font size and a color attached to it, which is just what we want. So we'll call that attr string. And that is type ns attributed string. And we're going to make a new one where we give it a string of our word and some attributes. What? No, it should not be capitalized.
How do you know to, like the attribute set within the method signature? How did you know to build that out?
Yeah, you'd have to look at the documentation. Yeah. Actually, yeah, it's not suggesting the right thing because it's attributes. And so I forgot to say this. So when it pops things up for you, you can use up and down arrows to select the thing in the little popover, and you can press enter to accept that that's the one you want to use. So that helps you type a lot faster when you start to get the hang of that. Mm-hmm.
From the method signature, how can I tell if the parameter is a name parameter or not? For example, why did you not use font size name parameter with the system font size call?
Very good question. A lot of times in a constructor, then they will use named parameters, but in just a method, they won't use named parameters. But the way that that we can do that, so we can look at our who here. So notice that when we called search, we didn't need to have a named parameter there. But if we declare it with a pound in front of the who, now we have to use that down here.
What are some examples of apps that like on the attributed string constant, like the what are some examples of apps that you would use that on?
Yeah, so let me show you what you actually do with that. So now in our sidebar it says hello, but if we click on the eyeball, now we can see that we actually have the word hello in 42 font size and cyan color. So what we're actually doing is we're preparing it for make it into a real view. We could keep typing, but let me just kind of show you the end result of what we can do here.
And why is it still using some Objective-C stuff like that?
Oh, because there is no attributed string in Swift yet.
So can you just drop in any Objective-C class?
You can use all the next step classes. Yeah, I think so. That's so far that I know of. Yeah, right. Yeah, so far that I know. Yes. Uh-huh. Let me come see.
Try if you have
How do you make the background black like that?
No. Comes with some themes.
Is it because you have two things named the same thing?
Yeah.
I have a light back.
You feel like
Yeah. Yeah, cool, that's good. You
Yeah,
know that,
in your activity sequence, right?
Okay.
Can't go over. It throws a lot of errors.
Yeah.
6-1.
Do you have a simulator open?
Remember the activity? So we have activity, just go to search and just hit
Like,
you want.
Automatically creating that file or you whatever you of the system.
Yeah.
It's pretty confusing.
What are you guys talking about over there?
Oh, the timeline output as opposed to the
Oh.
sidebar output.
Yes. Okay.
How, like,
Let me share that real quick.
How did you get the file view on that?
So I actually don't know how to make that happen, but the way that I do it is I select multiple files in Finder and open them at the same time.
Okay.
So
Command 0.
Command 0. Okay, there you go.
All right.
So what they were talking about is in a loop. You can actually look at the output over time. So let's just look at this little for loop here. So for x in the range of 1 to 10, or in this case it's 1 to 9. We're going to multiply x times x. And if we click on the little value history button, which is a circle, then it'll open up and we can see that it's kind of an exponential curve there. And we can look at each step of the iteration and see what x was. So here, I'll put it back so you can try typing that in.
Just the graph, did you do something for the graph, or is the playground like drawing the graph for you?
The playground just automatically draws it for me. And so all you have to do is hit the little circle button in the sidebar right here. And it makes it for me.
I was starting on this a month or two ago, and I was kind of working with it. And they must have fixed or changed a lot of things, because a few of these operators look a little different now.
Yeah.
And then also, I had a lot of trouble with the code hints showing up in the regular thing. And now that they seem to work now,
Yeah.
so I hung it up because it was so frustrating. So,
Yeah. It's much better with the code hints, especially now. Yeah.
Hopefully not work as advertised.
So yeah, so if you so if you just type in this little for statement right here, and then it says it ran 9 times, and you click on the circle next to the 9 times, then it shows you the graph. So did everybody get that? Okay.
Also, if you're in an actual project, not just a playground file, if you click on the system editor,
Then it can do it.
it'll take you to the timeline view.
So so let's look at our designing that we were doing. So here we've got our hello. That's, if I can do it, our cyan colored hello. Now we could make a frame by creating a new CG rect that's 200 by 100, and then we can make a view using our frame, and then we're going to set that view's background color to red. And so let's look at what that looks like. I could if my computer wasn't frozen. That's sad. Okay, there we go. So we've got a red view now. And then we can make a new label with our same frame.
Playground, if you click on where it says left A frame, CG rect, can you do,
This one.
yeah, can you go right to the right hand end and what would that look like? Okay. So how does it do the coordinates? The coordinates are,
Yeah, I guess so. It gives you a little scaled down version. Yeah. Which is pretty cool. I haven't actually tried that. That's cool. And so then we can set our label to the attributed text that we made, and then we can add our label to our view, and what do we end up with? A hello on a red background. So a lot of code, but when is this useful? This is useful for if you are designing a table view cell, then you would probably do something like this.
Do you know if they added the UI kit support? I was trying to do something like this when I was doing animations
Uh-huh.
in UI kit, and apparently at the time it was only supporting Cocoa, it wasn't supporting iOS.
Yeah, so now it should be fine.
so is it as simple as switching out the Objective-C view of the world, square brackets to parentheses?
Yeah.
Same classes.
Yeah.
Same members.
Yep. Yep. Yep.
Okay.
Just have to learn the new syntax. So I know some of you guys are still copying, but I'll just kind of move it up here a little bit. So now, what if we wanted to actually work with an image? Well, there's a little bit of a trick. In the playground, so I have the instructions right here. You can right-click on your playground file, show page contents, and then make a resources folder, and anything you put in there is accessible in our code. So now we can put some images in there, and we can use them inside of our playground. And don't worry, because I'll give you guys all this code when we're done. So if we make an image view, that doesn't have anything. But then if we make an image view and then we make an image named Dave, which is just like dave.png in our resources folder, and we set that for our image view, then we get Dave there. And if we add this image view to the view that we had earlier, let's do that, then we see that we have the hello label and Dave in there too.
Where does it put Dave?
So I set that because I did X150 and Y30, yeah.
And that's the
So
top
otherwise,
left corner of Dave?
yeah, the top left corner of Dave. So otherwise, if that's 0, 0, then it would have been in the top left corner of our view. Yeah.
Does like on the with the images comment there and then everything down there, does that go above the loops? You were doing the loops earlier.
But yeah, that's okay. You can leave the loop in the middle. It's fine.
You test constraints in the playground as well?
I haven't played with constraints in a playground yet. That'd be fun though. But yeah. I mean, if you do constraints in code, then you probably can.
Yeah, can you add constraints for the back?
Yeah.
Yes, about the playground resource.
Yes.
So I'm looking at the playground here.
Yes. So
Package contents.
show package content. There is no resources folder, so you just create one.
Just create one.
Yeah.
It just goes in there because you just put it right. Okay.
Yeah.
I'm still kind of,
You still can't open the file?
nope, another play must have been before.
That's crazy. All else fails, restart the computer. Maybe.
Now, does it matter if there's like a space between the colon and the number on the image view, or is it?
Like this.
Oh.
Is that what you mean?
Okay.
Yeah. I don't think that matters.
What is the dot scale aspect fit? The
Yeah.
same dot?
So that means, so I made our frame for the image view 40 by 40. And so this means that it's going to shrink the image itself down to fit in there. Because otherwise it's a big image. You know, so let's comment that out and then see what happens. So now when I look, oh.
No, it's an enum.
Yeah, it's an enum. It seems to still work. So I guess we don't need that because maybe it does that by default for us. But this is an enum, and we can talk about those next if you want.
That could seem a little weird. Like instead of width, it almost says wide.
Really?
It's CG vector.
Huh.
So I'm just, like I type.
Yeah, some of the older, like the NS stuff and the CG stuff, it doesn't provide you the very good hints.
It just says wide.
Yeah. So so before we get to enums, I'll just kind of quickly go over a couple more things. So let's say we wanted to create a minion object. So each minion, they have a name, they have an image, and they have a favorite activity. And when we make a new one, we want to be able to pass in the name and the favorite activity. And then we're going to provide a description function so that we can create a minion and then call for its description. So if we say let minion Bob, and we'll make a new minion with a name of Bob and a favorite activity of orbiting Earth. And then if we call minion Bob's description, then we get minion Bob likes orbiting Earth. And if we call minion Bob's image, then we press this, then we get his image. So that's how you can start to do object-oriented programming.
If you went in Playground,
yeah,
and you wrote that, where would it return the Minion Bob image to? Because you've not assigned it.
Yeah, so in Playground, they kind of let you do this kind of stuff where you just get something. Right. Yeah. But in a real app, it wouldn't let you do that. Yeah.
It wouldn't let you, or
it wouldn't let you. Yeah. If you try to build and run, it'll say error. Yeah.
Why are you saying self-image equals UI image?
This one. This one. Okay. Because when I call this image named name, that actually returns an optional UI image. And so in order to make sure that I always can get an image, even if there's not one named something, like even if like I don't have an image for that thing, then if I get an image, I put it in there, and if I don't have an image, then I just give it a blank image, basically. Yeah. Well, it's just a blank image by calling this UI image constructor. Yeah.
But what happens if you set it to nil?
So if I set it to nil, then I need to up here. I need to declare that my image is an optional UI image, like that. Yeah. Yeah.
So you have to.
Yeah. Yeah. Everybody good on that part? Okay. So now we get to tables, and I said that you could design a table view. Now we can do that. So we have an array of minion details here, and we're gonna kind of initialize them, and then we're gonna put.
What's you overriding?
What'd you say?
I saw there was an override in it. There. What's you overriding? Is there an init that's printed by default?
Yeah.
Because so this minion data source inherits from both NS object and the UI table view data source protocol. So those already provide it an init function. And so we're saying, no, we don't need their init. We're going to use our own. So that's why we put override.
How, wait, so that, I don't know if you answered.
No, that's
this,
okay.
answered
Go
this, But how would you know when to use override?
It'll tell you.
Yeah, let's see if it tells us. Yeah. So it knows that we need to override it because we're inheriting from these things up here.
There's no super in it.
No. Yeah, in this case, we don't need to do that.
Well, you can.
You
run
can do that.
from inside the init function. You can run this. It's like super dumb.
Yeah.
So, in that case, since you're inheriting from two classes, which one will
So that's where Swift is a little bit funny because the syntax for inheriting from a class and implementing a protocol. So what implementing a protocol means is that your thing has certain methods, right? And so the syntax for both those is the same. So you could just chain them together with commas. And as far as which one it takes, I'm not sure if it's like the first one or something like that. I don't know. Do you know by chance?
I don't.
Yeah.
I wondered that myself.
Yeah.
I also think that's a really lame way to.
Yeah.
Think you're overloading.
Yeah.
I think maybe probably protocols and objects aren't the same thing, so it just knows that the first object it finds is probably the parent, and everything else it assumes is protocol.
So if you've ever worked with tables in iOS development before, you know that you have to implement a lot of code that you wouldn't imagine that you would otherwise, but this is what you actually have to do. But the result is down here. So we make a new data source, and then we're going to set up a frame and set up a table view, and then set our data source to be our data source. And then when we reload the data, bam! So we can actually make a whole custom table in a playground.
How does it come up with those images? Like you have the names and stuff.
Yeah.
Get that.
Yeah, so the names of so down here, we're making a new minion for all the minions that we have, right? So our it's going through our minion details array and making a new minion every time. And then we are, so here we make an array of minions. And each time we create a new one in our loop, then we append it to the minions array. So now we have a minion array full of minions. And then down here, we're going to access each one of those. And then we're going to get its image and set it to cell.image view. So you probably have to like take the code apart a little bit.
Okay, well, does it get the images from like an external?
Yeah, so they're in the resources folder that I was talking about earlier, and they're named just whatever the minion's name is. So bob.png. Yeah.
I just like the first thing that comes to mind is that when they get them from like the emoji, the same kind of place, like all the emojis come from. And
I will show you a cool way to use emoji before we're done today too.
One thing that's also worth noting is you're creating an array of minion objects there.
Yes.
Because whenever you try to fetch an index of an array, it's always an optional.
Yes.
You don't have to declare the class optional in the definition.
So what? Where?
So like, what tripped me up when I was first learning was like, whenever I create an array of something, I have to declare it as an optional because you never know how many you're going to get passed in.
Oh, right. Yeah.
But because it's an array, it already takes care of that for you. So you just, in that case, you didn't actually assign any minions.
Right.
At that point.
Yeah, this is just an empty array. Yeah.
Whereas if you're going to assign optional minions, wrapped optional minions, then you would.
Yeah. So if I did this instead, then I could have an array full of optional minions, which would mean I could put nil in there too. Yeah. Yeah, each one of them.
So you could,
Yeah.
which means your init could return a nil if it was
Yeah.
properly.
Yeah.
But that means that all of them will be
Yeah.
properly.
Yeah. Cool. So we made a table inside of a playground. All right, let's talk about enums.
So, what's the reason for making a variable as opposed to a constant? The array?
Good question. So right here. So the reason, so if we make this a constant, so if I say let, now when I try to add a new minion to it, then it won't work because it's constant at an empty array. Does that make sense?
But I thought the array, the reference to the array could not change, but the contents of the array can change.
Does my program still work? You are correct. That's good. Yeah. So apparently, yeah. So just as long as we don't make try to assign a different array to it. Then
Is there a way to specify immutable arrays or immutable dictionaries in Swift? Well, that's the reference, right? Like,
yeah. Apparently, yeah. I thought that was the way, but yeah, that's not right. I don't know now.
That blows my mind. Yeah, I had no idea that either.
That's a good call.
So I think there are immutable data structures within this use.
Yeah.
We need to
Okay.
call
I'll try to let me make a note of that because I'll try to figure out what that is.
You can call it as immutable dictionary if you want.
Yeah.
Then you're not dealing with the dictionary.
Okay. So if we imagine a train can either be on time or delayed. And if it's delayed, it's always delayed by some number of minutes or some amount of time. So we're going to make an enum for the status of our train. And that's what it looks like. And this should be, yeah, you can try writing this if you want to. So then, for example, we could say let good news, and we could do status.onTime. So enums are kind of a way that you can set a state of something and do it in kind of an English readable way instead of doing it with a number.
That's new, right? Enums didn't just have that.
Yeah, they
You
didn't. Yeah,
just list out your,
right.
Yeah.
Yeah.
That was it.
Yeah.
So what's the case? What does the case mean?
That's just how you do it.
That's just how you do it.
Yeah.
Okay.
And so then if we make a train, then it starts off with the status as on time. And then if we wanted to make a description for our train, now we can use the status in a switch statement, and we can provide a case for each one of them. So if it's on time, we're going to return the string on time. If it's delayed, then we can use this cool kind of let where syntax. So we're going to use the number of minutes we have, where we've got a range from 0 all the way up to 5 using minutes. So then we can print out a slight delay of the number of minutes. I think it's because we're using the range.
Oh, is that binding? Oh. Yeah, it's bound.
I'm not too clear about why you'd need that. Yeah.
And use the tilde equal operator.
Where range contains value. So yeah, so I guess it's because of the range, yeah. And then the underscore thing is something kind of new, so that just means we don't care about, so it delayed by anything outside of the the range of 0 to 5. Then we just print delayed. And so we can make 3 trains, train 1, train 2, train 3. And we're going to set the status of train 2 to be delayed by 2 minutes and status of train 3 to be delayed by 8 minutes. And now if we print out all of their descriptions in the sidebar, we can see what happened to them.
This is a very interesting background project because I want to know how you added those comments. So there is code and there is comments.
Yeah, it's HTML code, and there is a way to do it. I haven't tried doing it myself. This is actually from Apple.
So
You can do that though, somehow, yeah.
Then if you look at you open it up and look at the resources.
Yeah.
It's like a bunch of HTML documents and also playground.
Yeah. So it's kind of a cool way to like make an interactive book in a way. Yeah. 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 So that's that. And then I just wanted to show a couple more things here. So Ernesto mentioned SceneKit here. So when Apple released Swift, one of the things they did was show off this playground file. And so it's called Balloons. No, I'm in the wrong one. Wait, sorry. Hopefully my computer doesn't blow up. SpriteKit, I meant to say. So SpriteKit is the 2D game framework. And so Apple released this called Balloons. So if you want to show the assistant editor, but you don't have a value history button to click on, you can just go View, Assistant Editor, Show Assistant Editor. And we can see that we can actually design like a whole game in the sidebar here. And so when these objects are shot of the cannon and they hit each other, then they delete themselves. So that's just kind of a fun little sample app. And you can go through the code and it has the book about what's happening in there too. So we can look at one with SceneKit. So SceneKit is the 3D framework for making games. 3D, yeah. And so if we show Assistant Editor this time, then we can actually see that it makes these toruses and makes them animate and spin around. So that's pretty cool. And then so we'll go back to seeing some more hardcore Swift stuff. This means we can have the triple dot means we can have any number of parameters inside of a function, and the any means we can have any type passed in. So in this case, we're going to call count params with one string in there, and the result it gives us is 1.
So you could write in dot, 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 any number of events.
Yes, we could do that.
And when do you normally do that? Write the right count?
That's a good question. I don't know exactly what you would use this for. But then we could call it with 2 strings, and it's going to give us 2, and 3, and it gives us 3. We could have optional parameters. So if you set them to a default value when you declare them, then that means you don't have to call them. So now we're calling the optional params function without anything in it. And this is a one-line if statement. Have you guys all used one-line if statements before? Yeah. Yeah, exactly. It's a great way to have bugs. But basically what it means is if 1 and 2 add them together and they still give you an empty string, then we're going to return nope. Otherwise, we're going to return 1 and 2 together. So our params added together.
And what's with the question mark?
Yeah, so the question mark, so this is like our if part. This happens if it's true, and the colon means this happens if it's false. So it's a short way to write an if statement. if else.
That's structuring to C.
Yes, it does. Yeah.
Does a plus sign work like a JavaScript? So if you have two strings.
Yes. So that's what we're doing here. Yeah.
Okay,
Yeah.
Well, you're in the multiple parameters thing. What about the tuple? Okay, like they use that to return multiple values.
Yeah. Yeah. So let's see. Yeah, we're gonna do that in this one here, actually. So so you guys see what happens. I can call it with just the 2 parameter, or I can call it with both, and then it returns the right things. This one introduces a number of things. So we're gonna learn generics and in-out and tuples. So generic means it can be any type, but they're both going to be the same. In our case, we're going to use 2 int values, but we could use 2 strings and it would work just the same. So that's when you use this kind of uppercase T syntax and then the T bracket on the outside. So that's called generic. It means you can pass in any kind of generic type in there. And then the in-out means whatever we pass in, we're going to return right back out. So we do that for both of our parameters. And then we're using a tuple in here. So we get passed in 1, 2. So 1 and 2. But we're flipping them and we're setting it equal to this tuple of 1, 2. And so what it does is it just swaps the values that are in there. And so, yeah.
Will it still work without the in-out added to it?
No. Yeah, that's important. So I'll delete it just so we can.
In-out, the like method signature version of the ampersand. The ampersand signifies that you're going to change this variable.
Yes.
The method will change this variable.
Yes.
Does the in-out allow you to use that then?
Yeah, so you can see we have the ampersand down there. And so we're just kind of declaring that we're going to change these values, the value of them.
A lot of magic that's going on behind the screen for this copy, behind the scenes for this copy. You'd like save it into a third variable and swap them around and then copy it.
Right.
I'm doing that.
So that's what this in-out is allowing us not to have to do. Yeah. And so we start with A5 and B9. Then when we show it at the end, now A is 9 and B is 5.
Oh, it's mutating the variables.
Yeah.
Places.
Yeah. And so we can do the same thing with strings, hi and howdy, and then we end up with howdy and hi.
What's the reason? Yeah.
I think is that telling it like its memory location?
No, it's just saying it's safe for modifying.
Safe for
So
modifying.
normally, like when you pass a variable into a method, it's not, the compiler doesn't want you to modify that variable. And the ampersand is just saying in this case it's okay.
My understanding of Swift was that when you pass a variable into a method, unlike Objective-C, you're not passing a pointer, you're passing the actual variable. It wasn't passing by value, it was passing the actual variable. So in that case, why would you need to say, I guess you could say, and it's safe to modify this variable. You're not passing a pointer to the variable.
Well, maybe it is the pointer, because at the other, you're not actually, the method doesn't actually hand back anything. It just modifies the variable, and then next time you use that variable, it's modified. Which would mean that, yeah, you passed on identity.
Yeah.
I think it's the address operator, so it does return an address.
That's pointing.
So you're saying that it's not really passing variables in and returning value, it's just modifying the variables that you.
That's right.
And so you couldn't pass, and the T there is saying that they can be any type, right?
Yeah.
Angle brackets. So, but they both have to be the same type.
Yep.
Okay.
Yeah, that's right.
So I was picturing if they're not the same type,
Right.
it's going to be a big problem, right?
Yeah.
Or that, all that other stuff.
Right.
Like, is going to work correctly, maybe.
Yeah.
You know.
Yeah, so I think that the type of the way they
Yeah.
try to fix that.
So I'll just skip down here to show some kind of cool stuff. So it comes with this sorted function. So right here we have an array 3, 2, and 1. And if we call sorted on it, then we can see in the sidebar it gives us 1, 2, 3 back. so ascending order. And we could do that with strings, and it would sort it alphabetically for us. So you see Alex is now first.
Does that actually rearrange the array, or is it just displaying it in sorted?
So no, it does not. Yeah, it's just returns
Really
the.
pass it over to him, so.
It has to be declared. We have to extend sorted to use in out. Yeah. So this section can kind of help teach about how we can simplify expressions all the way down. So let's say that instead of sorting the names, you know, ascending, we want a descending list. So we want them to be reversed. And so what we're going to do is create an array that's just ready to go, empty array of strings. And
before, when you declared an array like
that,
you put parens after the string square brackets. Why have you not done that?
Yeah. So this isn't actually initialized. It's just it's waiting to be initialized.
So if you put the parens, it runs an int.
Yeah. Exactly. Thanks for coming. So now we're going to make a function that will sort for us. So backwards is going to return a bool, so true or false, if the first thing is greater than the last thing. Okay? So we'll pass in sorted names, and we're going to pass in a function. So that's something cool that Swift can do, is you can pass around functions. And so sorted is going to take all the names, and it's going to run them through the backwards function to get true, you know, true or false, true or false. And in that way, they can be reversed. And so we see that now E is the last character there. We can see they're reversed. But we can simplify this down because this backwards method is kind of a long way to do it. So we can just pass in a closure instead. So the closure syntax is open and close curly brackets, and then we have parameters, and then we have a return. So this is an arrow, so dash, and then greater than sign and bool. So it returns a bool, and then the in keyword is what's actually going to happen. So that's where the curly braces are in our function up there, and S1 greater than S2. So now we, instead of declaring the function ahead of time, now we just put it right in line when we're calling sorted as a closure. But we can do that even simpler by putting it all in one line. So now our closure is just on one line. Because it's separated with the in keyword, it's okay for the return to be on the same line with everything else. And then we already know that these should be a string because of the type that's in our names. So we just can put S1 and S2. And then there's a couple of other levels, but they're not working right now in Swift. So we're going to skip over those. And we can get all the way down to this, where we just pass in the greater than sign, and it works.
It's very funny.
Yeah.
So it just reduces all of that other stuff.
Yeah.
So is that operator actually a function in Swift, or is that just like some magic it does?
It's an operator for strings. That, yeah.
Oh, is that just running? Yeah, because it's looking for a function, right?
Yeah. So it's like.
Everything is so obvious to it.
So like if you make a new type and you define that operator, the less than or greater than operator on the new type, can you just pass it in?
Yep. Yep.
Is that they can do some kind of accessing positional arguments and
Yeah. You can do horrible.
Exactly.
What?
It's just that the syntax for accessing positional arguments. $1, $2.
Oh, yes. I'll show you that. Yeah. Let's do map. So map, what it does is when we pass an array, then it runs some kind of function on every piece of the array that we give it. So every item in the array. And in this case, what we're going to do is we're going to multiply the item that we're passing in times itself. And the $0 means whatever the first parameter is that we pass in, that's what we're going to use. So you can access parameters like the first one is $0, the second one's $1, the third one's $2, like that. So this is just a really shorthand way of doing that. And so when we call numbers.map $0 times $0, then we get 1, 4, and 9. So we start off with 1, 2, 3. Now we get 1, 4, and 9. And so we can do the same thing for filter. So filter is going to keep whatever returns true. And so the modulo operator is like getting the remainder. And so when we take our number divided by 2, what's the remainder? If that's equal to 1, then we know it's odd. And we're going to keep that with our filter. And so when we print out odds, then we get 1 and 3 are the odd values that we have. And reduce, what it does, it takes an array and collapses it to one value based on a function that you give it. And the number you pass in to start is like the starting point. So we're going to start with 0, and we're going to take our array and add each number in succession together. So we're going to add the value we pass in and the next value. And if we do that, we get 6.
So the $sign number, right? That's the parameter. How do you know what the parameters are? I mean,
These are kind of let me show it in this instead. So this is a sum function, and so all we're doing is passing in a and b, and we're going to return an int, and we're going to add those together. So that works just like you would expect it to. So if we sum 3 and 4, then we get 7. Same thing. This is a square function, so we're going to multiply the number that we pass in times itself. So if we do that for 3, then we get 9. So now if we want to make a sum of squares function, then we can write this kind of complicated looking thing. But we just multiply the first number times itself, and we add that with the second number times itself. But if we wanted to make that more generic, then we could pass in 2 numbers, but also pass in a function. In this case, we're going to pass in a function that takes an int and returns an int. So this is just the syntax for declaring a function. And so now what that function actually looks like looks pretty cool. It looks simple. So now let's call the sum of function and pass in the function. So the fully verbose way of doing it is like this. So we take an int in, we return an int that's in this with a return of x times x. So all the pieces are there. But we know that x is supposed to be an int because we told it so in our function declaration up here. So we don't need to say that x is going to be an int. And we also know that we're going to return an int because we told that in our function declaration up here. So we don't need the return part. So now we simplify it down to just this. Then the first, if inside the function, the first thing you do, or you only have one line, then it knows it's supposed to return that. So you don't need the return statement. So we can simplify it down to this. And then now we can use our $sign because, so we declared that we're going to have a function that takes in one integer. And so that's where we can use the $0 times itself.
You just defined it already. So
Yeah.
it's already written up. So that's
Yeah. So because I declared a function that takes in an int, now I know I have one thing to multiply.
makes So
Yeah.
so the one, another one we look at, I didn't see, there was no
Yeah.
definitions of like,
Right.
where did that come from,
Yeah.
you know?
So those are map filter and reduce are built into Swift. Yeah.
It's a
And
little getting used to.
yeah, yeah,
So it's a snare, you know, when you get to the very end,
yeah. And so the point is that, you know, you can declare it with this verbose way, and the answer you get is 25 for 3 and 4. And if we do it even with this, you know, very small way, then the answer we still get is 25.
Can you just pass in the multiplication sign in this case?
No. And
So these are all the Apple docs.
this stuff is not in the Apple Docs.
Is that
Yeah.
the one you said was-
Yeah, when it has all the extra book stuff. Yeah, that it's in.
I like that. So it's actually a very cool way to.
So
Yeah.
where's
distribute that.
where's all this coming from?
It's from my reading, and then I created it.
So you have a file that I can look at later?
What'd you say?
Or you have a post that file?
Yes, I'm going to post this so you can open it and look at it. Yeah. Yeah, so that's all the Swift stuff. Did anybody have anything that we missed? No?
I noticed on some of the errors, like it'll say like a missing semicolon. Like, why does it? I mean,
Oh, that's lying to you. Something else is wrong.
oh,
Yeah.
Missing colon, you know,
So sometimes if you the reason why it's telling you that is because it thinks you're like having two separate statements on the same line, and so it thinks you need to separate them. But obviously you didn't mean that, so it just means that something's not quite right with your syntax. So like, what do two separate statements on the same line look like? If I do this, A equals 5, B equals 5. You know, it doesn't know what to do with that. But if I put that, then it's okay.
I
You see?
thought Swift didn't use semicolon.
So it doesn't because because if I do this on two separate lines, then it's okay.
It's like the JavaScript is the same line.
Yeah.
I don't care about the semicolon, but it's just used to separate statements because it reads the
Yeah.
term in the same way.
Yeah. So you can do stuff all in one line if you use semicolons between things. If you wanted to collapse the code down. Yeah, minify it.
Actually, I think a lot of languages do that. I think like
Yeah.
Ruby does that too.
Hmm.
You don't have to use a semicolon, but if you want to cram things on multiple
Yeah.
lines, separate it.
All right. So
Just curious, like what does that 2 times, 4 times, anything on the big number? What does that mean? You can get a chance to-
2 times 4 times.
Yeah, 3 times, 4 times, on the right side.
Oh, when the loops are running?
Oh, right here. Yeah. So why is it saying that?
Because that's just you're defining. Oh,
How many times will it run?
yeah, but he hasn't found, like for example, sum of functions. Like,
Oh. Because it's calling this function.
yeah, but if you go like the first one, the 4 times, there you're just defining it, right?
Oh, because yeah, it's counting how many times we call this function.
Elsewhere.
Yeah, elsewhere.
It's not linear.
Yeah.
It runs through the whole thing.
Yeah.
Until it's all done.
Okay,
Yeah.
okay.
That's
Yeah.
Have you gotten the 6.1? Have you gotten your app load up in your playground? Have you ever gotten that to work?
What do you mean?
Where you could like write methods and classes in your like project
Yes.
And I tried getting that to work and it could not figure it out.
Okay.
I think maybe that was the problem. You had to like have source, target. Directions I found were like I followed all the steps and it never actually
Didn't work. We'll try it. Okay, so let me show you guys what this looks like first. So this is a little watch simulator app that I built, and so what it does is it's kind of prototyping what it'll look like when you can get your heart rate in real time and see the number of beats per minute.
How much are these the watch is going to go for?
And so 350. And so this is an erratic beat. So you might have noticed that. And so we can review the rhythm strip over time. We see it's all going all over the place. Yeah.
Are these watches? Are they have like webcams so you can like Skype with people?
They don't have cameras. Yeah, not this first version.
So I noticed your simulator loaded about 5 times faster than Windows. You got this quite a lot of memory.
Yeah, it does. No. So this is a watch simulator that I made. And it's basically using an image. I'll show you. Although my computer is going slow now. So we have our view controller, and it's got an image with a container view inside of it, and then I have this app view controller over here.
How much memory is recommended to have in order to get the simulator to run?
Well, I like to have 8 gigs. Yeah.
So how big is how much hard drive space are these watches have?
8 gigabytes.
Thank you.
Yeah. Also funny. Same answer.
Oh.
Yeah. And so in here I have this beat pattern. So each beat pattern that can be recognized, it has an icon, which is a piece of emoji for the heart, and it has a description and a status, and then the number of beats per minute, which is optional because in our erratic one that we can't recognize the number of beats per minute, so we set that to 0. And then the duration we can calculate here by using the beats per minute. 60 divided by the beats per minute gives us how much time each beat takes. So now let's say we want to use that in our playground. So the way to make a playground in here is I can just right click and say new file. And if I go to iOS source playground, my playground 2. And so now, no?
Well, it's 3-2, the last out of the last inning.
Okay.
Maybe my
So now I have a playground inside of my iPhone app project, and so
you had main storyboard pilot when you started that. Does it matter?
no, it doesn't matter. It could be anywhere in there.
It's
Yeah.
not in main storyboard.
Yeah. So now I should be able to say var beat pattern equals. It seems to work. So now if I go pattern dot that's weird. It's not giving the error, but it doesn't. So you're saying I have to do something special to make it work?
Yeah, I could
Never get us to do it.
never get it to where you can actually use. I can actually get Objective C code in the project Like,
Okay.
I just created a dummy like Objective-C class
Yeah.
that had a bit on it, and that
Uh-huh.
would show localizes the Swift files to your project. That's somehow confused.
Okay.
I couldn't get it.
Yeah.
Because I thought that's all you had to do was just
Right.
create a prop layer inside your project. That's what they said. I think it works for Cocoa, but it doesn't work for.
Okay. Okay. But you can still like, test stuff out in here, and I'll make a note to figure out how to do that too. Playground project. Anything else? So bootcamp hackathon, and this is where I'll make a blog post with the code and notes from today, and then I'll post it as a comment in the meetup group too.
So you're just gonna post that to the meetup?
Yeah.
Great.
You can talk about the app that you're going to build.
Yes. So at the bootcamp, we will be making a version of the Heartbeat app, except we'll also work with an API to pull down like the beat patterns. So that way you can practice with networking and data storage.
Targeted for iPhone.
Yeah. So it'll run on an iPhone. So and then when the iWatch comes out, hopefully you can kind of reuse the code. Yeah.
What do you hope to see out of the hackathon?
So I hope that we get some cool like motion stuff. I mean, it'd be awesome if someone could make like a workout app that counts your reps as you go along, kind of walks you through a workout. And then I want to see someone doing something with like I don't know what the simulator is going to be capable of, but the vibration sensor or the vibration motor on the watch is super sensitive. So you could like tell if you need to turn left or right by the way it vibrates. So for GPS directions, say you're riding a bike, you don't want to be looking at the screen, it can just vibrate left and right.
Yeah, I find the watch pretty interesting, but it's like,
Yeah.
In order to really test it out, you're going to have to get one.
Yeah.
Like, the simulator is not really
Yeah.
for that kind of.
Yeah.
Are they going to ban those in casinos?
Right. Yeah. And then I also think it'd be cool to see some kind of a communication app. So even if it's as simple as like drawing pictures to send to each other, I think that'd be fun.
Calls on the watch. I mean, like,
You can do that. You can make calls. Yeah.
For the watch?
But you need to have your phone in your pocket.
Does
It's
it
gotta have a phone.
have a microphone on the watch?
Yes. Yeah.
what about like Kindle?
Can you
Yeah.
use the watch without the phone?
You can use it, but it won't have internet and it won't have GPS.
Yeah, because I remember reading this and it's key to your phone.
Yeah.
And I was wondering like with all the downloads, like it's not.
Yeah.
So you can have the time and listen to music. or
Right.
something.
Yeah.
Yeah, thanks a lot.
Yeah, my pleasure. My pleasure.
Very good there.